This is Algebra 1, Lesson 3.4, solving equations with variables on both sides, more specifically both sides of your equal sign. That's what we're doing. We're collecting variables on one side of an equation, then we're doing it in real life problems. Once the variables on one side, we're going to use it. We're going to solve them just like we've been doing the multi-step equations from before. Beginning on page 154 in your text. First thing you have is a definition of what an identity is. Now, we've already talked about the identity property, so this is just an extension of that. An identity is an equation that is true for all values of the variable. When you have something that eliminates the variable completely, and all you have is an equal sign with a value like 2 on the left and 2 on the right, notice this is a true statement. Therefore, it'll be an identity. What that means is it doesn't matter what value you plug in place of x, any number will make it a true statement. And when we get to those examples, I'll show you exactly what that means. Example number 1 is collecting variables on one side. So you have an equation, and again, we talked about this very briefly last week. 4x minus 10 is equal to 32 minus 3x. You have on the left side and the right side, you have a variable x. You want to move the smaller x value. In this case, you have 4x on the left. If you separate it left and right, and negative 3x. Remember, the sign goes with it on the right. Move the smaller one over to the larger one side. 4x is bigger than negative 3x, or negative 3x is smaller than 4x. So bring that smaller negative 3 over. Negative 3x is the same thing as minus 3x. So undo. We know how to undo minus something. You add 3x to both sides. So when you add 3x to the right, you do the same to the left. You add 3x. Remember, anything you do to one side, you do to the other side. So here's the horizontal version saying the same thing. Add 3x to each side. When you do that, it eliminates it on the right-hand side. And when you put 4x and 3x together, you get 7x on the left-hand side. So 7x minus 10 is equal to, since it's eliminated, you got 32 on the right. Now you got an equation that's just two steps that you know how to solve, just like before. Undo minus 10 by adding 10 to both sides. So add 10. And if you add it to the right, left, you add it to the right. Again, you always do the same thing. Here's the horizontal version right below it. Adding 10 to each side. Minus 10 plus 10 is going to cancel out. This is going to cancel out. And you're going to be left with 7x on the left is equal to 42. Then it's as simple as undoing the multiplication of 7 times x. So divide by 7. And when you divide each side by 7, because you got to do the same thing on both sides, 42 divided by 7 we know is 6. So x is 6. So now we have a value for x. X is 6. So right below that, it tells you to check to see if that's correct. Take your value of x, which we just got a second ago, x is 6, and in place of x, we're going to plug in the number 6. So we're going to sub it in. So instead of 4 times x, now 4 times 6 is minus 10 is equal to, and notice there's a little question mark above that equal sign. It might be small on your paper to read, but that's a little question mark. Just want to know, is it equal to 32 minus 3 instead of times x times 6? So your multiplication, your order of operations says do multiplication first. 4 times 6 is 24. I do everything all in one step. But 4 times 6 is 24 minus 10, which is 14. And negative 6 times 3 is negative 18. So you have 32 minus 18, which is 14, and 24 minus 10, which is 14. So you have something that says 14 is equal to 14. That is true. So by checking it, you found out that x is equal to 6, and you checked it to make sure. Most of the time, checking is something you want to do mentally. You don't have to write this checking part out, but you always want to plug it in and see if it works, just to make sure you didn't make a mistake. And more often than not, when you do make mistakes, it's not because you didn't know how to do it. It's because you forgot something had a negative in front of it. Or when you multiply negative times a negative, you put a negative something instead of a positive. You did something simple like that. You knew how to do it, but you made a very small mistake. On the back, where there's some room, plenty of room on the back. Copy this problem down and work to solve for x. Remember, collect your variables on one side first. 6x plus 22 is equal to negative 3x plus 31. Take about 45 seconds. Okay, we have variables on both sides. We got a left side and we got a right side. We want to get at the end, we want to get x equals by itself. That's still our goal when we're solving equations. But we have 6x on the left. We got negative 3x on the right. Negative 3x is smaller, so we want to bring that one over to the larger 6x side. Negative 3x is the same thing as minus 3x, so undo that by adding 3x. If you add it to the right, remember, do the exact same thing on the left. 6x plus 3x is 9x. You still have plus 22 here, equals, this part's gone. You still have positive 31 there. We brought our 9x over to the left. So bring the constant terms, the ones that don't have variables, to the other side. In this case, it'll be the right. So undo plus 22 by subtracting it. If you subtract it on the left, do the exact same thing on the right. Now you still have 9x on the left equals 31 minus 22 is 9. Then get x by itself by undoing 9 times something and dividing by 9. If you do it to the left, same exact thing on the right. X is 1. Check and make sure it's correct. 6 times 1, just subbing it in place of x, plus 22 equals negative 3 times 1 plus 31. 6 times 1 is 6 plus 22 is 28. And negative 3 times 1 is negative 3 plus 31. Opposite sign, subtract them, is 28. Notice we have a true statement there. 28 is equal to 28. Therefore, x is 1. Also do this one. Do it right next to it or right below it. 64 minus 12w is equal to 6w. Take about 30 seconds on this one. Again, you got variables on both sides. You want to get w equals all by itself. You might have it written backwards, but it doesn't matter which way you write it. Your negative 12w is smaller than your positive 6w. So let's bring negative 12 or minus 12w across by adding 12w. If you add 12w to the left, do the same to the right. 12w plus 6w, or the other way around, is 18w, is equal to, we still have 64 on the left. Now undo 18w times something by dividing by 18. If you divide the right by 18, divide the left by 18, the exact same thing. And then 18 goes into 64 3 times. Notice it's written backwards, but w is equal to 3. Back on the front. Does something have many solutions or no solutions? Many solutions being all real numbers or an infinite amount of real numbers. So let's look at the first one. It says 2 times 4x plus 5 is equal to 8x plus 10. This is dealing with identity problems. 2 times 4x, you just distribute it, is 8x, and 2 times 5 is plus 10. So 8x plus 10 is equal to 8x plus 10. Notice it says the exact same thing on the left that it does on the right. But for the sake of following the exact same steps as we did a second ago, let's collect our variables on one side. Now, it doesn't matter if you bring the 8x on the left over to the right, or if you bring the 8x on the right over to the left. Let's say we did that. Let's say we took this 8x and brought it this way. You would undo positive 8x by subtracting it, and it'll cancel out. And when you subtract 8x over here, you're going to get something likewise. Now, let this be one of those alerts to you, or let this be one of those red flag problems that pops up. We just eliminated the variable from the problem. We eliminated the variable. The 8x is gone now. So now we got something that says 10 is 10. The x's, all of the x's, the variables are gone. Anytime the variables disappear, it's either going to be no solutions or all solutions. The way you determine if it's none or all of them is, do you have a true statement? Is 10 equal to 10? Yes, 10 is in fact equal to 10. So it'll be all real solutions. So the answer is all values of x are solutions, because you're going to plug in the same value on both sides. It doesn't matter if you plug in 1 on both sides. It doesn't matter if you plug in 100 on both sides. It doesn't matter if you plug in negative a million on both sides. It'll still be a true statement because the variable will be eliminated. This problem is always true, therefore it is an identity. A is an example of an identity. Now let's take a look at B. B says x minus 1 is equal to x plus 7. Again, same thing. Let's collect our variables by moving this one over and subtracting the positive x. If you subtract it there, you subtract it here. Now what you have when you do that is something that says negative 1 is equal to 7. Anytime you see that little slash through the equal sign, it's just telling you that it's not equal to 7. But the statement would say negative 1 is equal to 7, and we know that that is not a true statement. Unlike 10, which was equal to 10 from A, this one, negative 1, is not equal to 7. That is something that is not a true statement. What that means, it doesn't matter what number you plug in place of x, you will never get a true statement. It doesn't matter if you plug in 1. It doesn't matter if you plug in 100. It doesn't matter if you plug in negative 1 million. It will not work. Therefore, you will not get a true statement. So there is no solution. You can write the word no solution. You can write x is, here's a mathematical term for you to use, null set. That means there is no value. Or you could simply write this, x is no solution. That is mathematical shorthand for there is no value that will make it correct. So let's try two that look just like that on the back. Solve this equation. 4 times x minus 5 equals 4x minus 20. Take about 25 seconds on that. Okay, you know, before you try to bring anything across, you have to eliminate unnecessary grouping symbols like distributing. 4 times x is 4x. 4 times negative 5 is negative 20. Now, at this step, if you are confident enough, you can clearly see that it says the exact same thing on the left as it does on the right. Notice it says the exact same thing. That's going to be an identity. But if you can't quite see that, collect your variables on one side. Bring this one over by subtracting 4x since it's positive. Subtract it here. Your x's are gone. You eliminated them. So you still have negative 20 on the left and you still have negative 20 on the right. Determine if that is a true statement or not. It is. Negative 20 is equal to negative 20. So here's another mathematical shorthand for you. You can say x is all real numbers, or you could simply say x is, you just put yourself two lines like this, and you draw a capital R. There's mathematical shorthand to say x is all real numbers. That means no matter what number you plug in, as long as it's not a complex or an imaginary number, will make this work, and some of them will as well. Okay, so right next to that one, or right below that one, do this one. 3x minus 9 equals 3x plus 10. Take about 25 seconds on this one. Real quick problem. Okay, 3x minus 9 equals 3x plus 10. Collect your variables. Bring 3x over by subtracting it since it's positive or plus. Undo 3x there, undo it here. You're going to get no more x's there, eliminated. You still have negative 9. You still have equals 10. Evaluate this to see if it's true or not. Is negative 9 the same exact thing as 10? Is it equal to it? No, it is not. Therefore, there is no solution to x, or there's null set. There is no value that when you plug it in place of x, that will give you a solution. So the next one is solving more complicated equations. Now you're just taking the stuff we've been learning and you're just kind of jamming it all together. This one says 3 times 2 minus x plus 2x is equal to negative 5 times x plus 2. So before you try to go across the equal sign, completely simplify each side. So if we look just at the left side, 3 times 2 is 6. 3 times negative x is negative 3x. On the right-hand side, do the same thing. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. So that's just using the distributive property. You still can't bring anything across because still as you're looking at just the left-hand side, you have like terms, negative 3x and positive 2x. So put those two together. Negative 3 plus 2, opposite signs, you subtract them. 3 minus 2 is 1, and keep the larger absolute value, negative 3. So it's 6 minus x equals negative 5x minus 10. Now it looks just like the problems we've been doing from example number 1. Bring your smaller x value over to your larger one. Now, this is slightly tricky to some people, this part right here, because this value right here is negative 1x. The other one is negative 5x. Which one is smaller? The negative 5x is smaller, even though it looks like the negative 1x is. Remember, negative 1 is farther along to the right if you're looking at a number line, and negative 5 is further to the left, which makes it smaller. So if we want to bring the negative 5x over, we undo minus 5x by adding it, just like example number 1. If you add it to the right, add 5x to the left. Now those are opposite signs, negative 1 and positive 5, so subtract them. 5 minus 1 is 4x, and keep that larger absolute value, positive 5x. Notice now we have 6 plus 4x equals, the negative 5x is gone. So you still have negative 10 there. Since we brought 4x to the left, bring 6 to the right. It says positive 6, so subtract it. If you subtract it there, subtract it here. Negative 10 minus 6, same sign, add them up. 10 plus 6 is 16. Keep that common sign negative. Now you got something that says 4x on the left all by itself equals negative 16. Undo 4 times something by dividing by 4, and a negative divided by a positive is a negative 4. Make sure off to the right you are filling in those blanks. Add 5x to each side, subtract 6 from each side, divide each side by 4. Because after you do a problem, in fact, after you do each step of a problem, you should be able to say exactly what you did in words. That way when you get to word problems, they're very, very easy because you can translate back and forth numbers to words and words to numbers. So on the back, one more. How tough is this problem? Don't freak out when you see a fraction. Very simple, in fact. 10 times 2 minus x plus 4x is equal to negative 3 over 10 times x plus 3. Take about a minute on this one, even though it isn't exceptionally hard. Okay, the left side of the problem is probably very easy for most of y'all to do, but then you got a little stuck when you looked at negative 3/10 times x. What we want to do is we want to distribute. First thing, 10 times 2 is 20. 10 times negative x is negative 10x plus 4x equals, let me continue with the left side just to show you that we can continue and we can keep going there. 20 minus 10x plus 4, our like terms are 20. I'm sorry, our like terms are negative 10x and 4x. When we put those two together, they're opposite signs, subtract them. 10 minus 4 is 6x. And since 10 was the higher absolute value, it's negative. Now it says 20 minus 6x. So that's just the left side simplified because we can't take those two away from each other. One has an x, one does not. Therefore, they're not like terms. The other one has a fraction involved. Now, negative 3 over 10 times x plus 3, we can distribute negative 3 over 10 times x and times 3. That would be totally fine. But most of us don't like dealing with fractions if we can help it. So what it says is negative 3. Here's the easiest way to do this. Negative 3 divided by 10. How do we undo divide by 10? How do we undo divide by 10? Multiply by 10. So if I multiply that term by 10, what's going to happen is it's going to eliminate it. But remember, if you multiply the right side by 10, what do you have to do to the left side? The exact same thing. That's correct. So we have to multiply this term and this term by 10. So 10 times 20 is 200. Now we dealing with bigger numbers, but 200 is much more preferable to 3 over 10 for most of us. Minus 6x times 10 is going to be minus 60x is equal to, that's gone now, we still have negative 3 times x plus 3. So now it should be easy for you. Distribute negative 3 to both of these terms. Times x is negative 3x. Times 3 is negative 9. Again, the problem is more complex, but now it should be easy from a step standpoint for you. Negative 60 is smaller than negative 3. So undo negative 60x by adding 60x to the left. If you add it to the left, add it to the right. Negative 3 plus 60 is going to be positive 57x. We still have negative 9 on the right, and we still have 200 on the left. So since we brought 57x, since we got our x's on the right side, undo negative 9 by adding 9 here. If you add it to the right, add it to the left. Now you have 209 is equal to 57x. Then undo 57 times x by dividing by 57. If you divide the right, make sure you divide the left by 57. Now 57 does not go evenly into 209, so we'll leave it in that form there. X is equal to 209 over 57. And let's take a look at our checkpoint problems. 6x plus 33 equals 5x. Variables on both sides. Now, what we've been doing up to this point is we always been bringing the smaller variable over to the larger one side. 5 is clearly smaller than 6. But since there's 33 on the left, we would have to move 33 as well. So in this case, let's bring 6x over to the right side. It's positive 6x, so subtract them. If you do it the other way, it'll still come out to be right. I'm trying to save a step right here. Minus 6x, 5x minus 6x is negative 1x, is equal to 33. And then get x by itself by undoing negative 1 times that by dividing negative 1. If you divide the right, divide the left. 33 divided by 1 is negative 33. So x is negative 33.